We have a couple of more events, actually 3 more events this semester.
I did that on the front of the whole fuel proposal.
To come to those events as well. The next one, which is not next week, but the week after, is Yvonne Everett, who's professor here on campus in the Department of Environmental Science and Management. Title of her talk is Collaborative Cross-Boundary Stewardship, International Comparisons of Challenges and Success. We also have talks on April 10th and April 24th, and I encourage you to look out for the flyers associated with those talks, as well as the poster associated with the series. Tonight, really pleased to have both Matthew and Colin speaking. Matthew Marshall is the Executive Director of the Redwood Coast Energy Authority and a great collaborator of ours at the Schatz Energy Research Center. So we're both appreciative of the work that they do, but also appreciative of the collaborations that we've been able to engage in over the past years and the ones we'll do going into the future. Before becoming the executive director of RCEA, Matthew was the greenhouse gas reduction program administrator for the city and county of Denver. So the work he's doing now was in many ways builds on that experience from Colorado, and he's also a local boy. Has a degree from here at Humboldt State University, and I was involved in a variety of things, including energy projects, while he was a student here. Colin Sheppard is a research engineer at the Schatz Energy Research Center, and a fantastic colleague to work with in his capacity there. And Colin was very involved in a lot of the quantitative analysis underlying this study. And actually not here in his bio, but prior work, he was a graduate student here at Humboldt State University and in the Environmental Resources Engineering graduate program. And he also has a degree in computer science, more or less. Calls something slightly different than that from Stanford University. So really pleased to have both of them here tonight. So please give them a very warm welcome.
Thank you very much. We're going to tag team it, so I'm going to kind of give the first section, and we'll pass it off to Colin to get into some of the nitty-gritty details. Let's see. So I'm just going to go over a little bit of kind of background for the project that we're working on and the sort of current status of electric vehicles, and then sort of, what's the, the benefits of electric vehicles in the broader sense, and then getting into, electric vehicle charging and what's that all about, and then looking specifically at what are we doing locally around electric vehicle charging and the project work and the planning work that we're doing. So the North Coast Plug-in Electric Vehicle Readiness Project is funded by the California Energy Commission, and they're actually funding a series of these regional planning projects across the state, and so we're one of those efforts to kind of have a coordinated strategy statewide, and we'll talk a little bit more about that. And we're just wrapping up kind of a 2-year effort this spring, so we'll be coming out with a sort of final readiness plan later this spring, and we've got a kind of a good project team that is built off of our fondness for blue logos. But it's actually, we've got it's a unique opportunity locally that PG&E has been engaged on this issue and across the state. But beyond that, our local team is sort of unprecedented. If you're not familiar with us, the Energy Authority is a local government joint powers agency. So we represent all of the local governments in Humboldt County, all the cities in the county, as well as the water district. And our mission is to work on energy efforts on behalf of all of those governments, which is fairly unique across the state, and particularly for a rural area, it's not something that's very common. So we kind of have a little bit more on the local government coordination side, and then also for an area of our scale, obviously having the Schatz Energy Research Center locally is something that most areas don't have, and certainly most rural areas don't have that level of energy expertise. And then we're also working with GHG Engineering, which Dave Carter is one of our team members there, and they've got both local and actually international expertise on these kinds of issues. So we were able to kind of put together a pretty crack team, which I think gives us some great opportunities to do cutting edge work, and not just things of local relevance, but actually of statewide and national relevance. So the goals of the project that we're working on is really to develop sort of a regional strategic plan to help facilitate the adoption of these vehicles. And we're going to talk about the vehicles that are available and that they're coming on. And so it's how do we not just let this kind of develop in sort of a business as usual capacity, but how do we actually kind of really push it and help accelerate that. And then part of that is doing some regional planning, developing regional guidelines for implementation and streamlining permitting, and kind of some strategies around that, and then also working with local fleets and working with outreach to the public to kind of increase people's awareness and help people realize that these are viable options for them to be picking as their vehicle of choice. So just kind of the big picture of electric vehicles, there's kind of two categories really, and there's full electric vehicles and then plug-in hybrid vehicles. And so full electric vehicles, the market right now, there's sort of 60 to 250 mile range, and that's a vehicle that just has batteries and electric motor, and so no internal combustion engine, no oil changes necessary. Completely dependent on the electricity. So there's Nissan Leaf is the most popular plug-in vehicle right now. That and the Chevy Volt are the two top ones. Tesla Model S is kind of one of the other sort of market share leaders. And that's what's got the 250 mile range is the Tesla Model S. And then on the other side of that, there's plug-in hybrids, which have a limited battery range of typically from like 10 up to 40 or so miles that they can run in sort of all EV mode, and you can charge them. And then once you exceed that, then it basically converts to being a conventional hybrid and operates like a conventional hybrid. And so there's quite a few conventional hybrids that have been adapted to be plug-in or have plug-in versions, like the Honda Accord. The plug-in Prius is the most popular of those. And then of a kind of purpose-built plug-in hybrid, or what they like to call an extended range electric vehicle, is like the Chevy Volt, where it was actually more designed from the electric side, but it has the ability to basically charge its batteries from an onboard generator. And so there's kind of a variety of vehicles out there. There's about 20 or so, maybe 20 plus vehicles actually available right now, and they're kind of scattered throughout this presentation in the background. And so there's quite a few options, and there's more kind of coming out this year and next year. So there's a good range of options of both full electric and plug-in hybrid vehicles out there right now. And as far as adoption, it's been going quite well so far. This shows the sort of the total picture of vehicles sold in the U.S. And California, I think, is about 60% of all vehicles are sold or so. So we're a large part of that market is here in California, thanks to some of our state policies. And as you can see, the split is, the green is the full electric vehicles, and then the plug-in hybrids are the blue. And so it's a fairly even split. And as I mentioned, the vast majority of those vehicles are either Nissan Leaf, Chevy Volt, plug-in Prius, or the Tesla Model S makes up the larger chunk of those vehicles, although there's quite a few that are available in addition to those. And so, as far as that, are we on a good trajectory? Are we not doing well? It looks promising from that graph. And so this is actually comparing the current sort of ramp up of how many plug-in electric vehicles are being purchased, comparing that to when hybrid vehicles first came out. And so the yellow shows hybrid vehicle sales back in 1999, 2000, 2001, 2002, when those vehicles were first coming out and first being adopted. So the first Prius came out, the first Honda Insight came out. And then the gray are sort of the same stages of, 2010 when plug-in vehicles first came out, 2011, 2012, up to 2013. As you can see, they're actually selling significantly better. The market share is increasing significantly faster than hybrids when they first came out. And so people are not shying away from plug-in vehicles. They're actually adopting them at a faster rate than hybrids when hybrids first became available. So that's a promising sign. And it's also, we're still in kind of sketchier economic times than back in the early 2000s as well. So it's a promising indication that people are interested in these vehicles on a broader scale. So as far as locally, one of the things we're trying to do is figure out, what's that going to look like for Humboldt County? especially as we're looking to one, try to increase that number, but then also trying to support it with the necessary infrastructure. And so the black line on the bottom there is sort of the business as usual projections for vehicle adoptions going forward based off of those hybrid numbers. So saying, okay, if people just kind of adopt these vehicles similar to people adopted hybrids, assuming that kind of the same type of folks are going to be interested in a plug-in Prius as they would in a regular Prius. That's sort of the business usual projection. And then the blue line is assuming what if we can go 10% faster than those hybrid sales, or the red line, what if we can go 25% faster than those sales? As you can see, that kind of just bumps up. So in the bottom there, it's showing, well, when are we going to get to 0.5% of the vehicles being plug-in vehicles? When are we going to get to 1%? When are we going to get to 2% of the vehicles? And so basically what we're trying to do with this project is move those, get to 1% sooner, get to 2% sooner. And so we want to be able to support that with infrastructure. And so the second phase of that is saying, well, okay, if we want to get up to that, 3,000 or so vehicles on the road in Humboldt County, what infrastructure do we need to support to enable those people to adopt these vehicles faster than they otherwise would? Plug-in hybrids, it's not as much of an issue. For the full electric vehicles, it's more of a concern of, is there going to be that public infrastructure to kind of support those times when you do need to charge, when not just in your garage, but when you're out and about during the day. And Colin's going to get into the full kind of nature of what are the charging options and what does that look like. So the electric vehicles are here. I actually passed a Tesla Model S on the way. Well, I should say it passed me when I was on my way here, just between Arcade and Eureka. I think 4 people or so locally, and so that's the high end of it. But there's been quite a few vehicles. People are buying them, and actually one of the main constraints has just been availability at the dealerships, because they'll get one in and they'll sell it or lease it right off the bat, and then they'll have to wait another quarter before they'll get another one in. And so for some of the models out there's actually been kind of a constraint just because they haven't been producing them fast enough to meet demand. And so that's another promising indication that we're not unjustified in trying to plan for this. So as far as what are the benefits of electric vehicles besides just an alternative? The key one is just the energy efficiency and fuel economy, that there's significant inefficiencies in internal combustion engines, and so an electric motor is just a better way to move a vehicle as far as efficiency, and that translates into lower fuel costs. And so if you talk about what does it take to drive an EV a mile versus a comparable gas vehicle, the cost of powering your vehicle with electricity is about half to a quarter of that, depending on what your electricity rate is and what time you're charging. But it's about a half to a quarter of what the cost of gasoline is to move a vehicle the same distance. And so that equates to basically paying like $1 to $2 a gallon for gasoline if you're charging a vehicle at home and using that. And so right off the bat, cutting your fuel costs in half is obviously a significant economic benefit. And then there's the further sort of environmental benefits of, you can potentially get that electricity from a local source rather than importing oil from outside the region or outside the country. And so you can use local renewables to meet that demand, as well as it being less expensive. And then actually the maintenance costs can be lower, especially for a full electric vehicle, because you don't have oil changes, and it's actually fairly streamlined piece of equipment. And I think Dave got the 3-year or so bill for the Leaf maintenance, and it was like a couple $100 or something for all the oil changes and all the dealer provided maintenance, and so they're actually cost effective in that sense.
All the oil changes,
which was zero. So it was the tires and tune up and all that. So and the environmental side of it, you're talking about. The emissions side of it. Obviously, if you've got a full electric vehicle, there's no tailpipe emissions, but there's also there's upstream emissions from power plants, but there's still significant benefits, especially here in California, where we have a clean electric grid, and Colin will show some numbers about that in a bit. I mentioned that you're not importing a fuel. You have the potential to generate your vehicle fuel locally, which that's one of the big challenges when we look at greenhouse gas emissions, is where's our, how are we meeting transportation energy needs? And I like to mention, this has got the Tesla up here again. That this high performance, and they're fun to drive. I mean, the Tesla is a 5-person station wagon that goes from 0 to 60 in like 4.5 seconds or something like that. And in the Chevy Spark ads, which is it's a little teeny compact car, they like to point out that it has more torque than a Ferrari, since the electric motor has great sort of off the line kick. So. We'll talk a little bit about an event where you can experience that yourself coming up this Saturday. So, they're not golf carts and they're not low performance vehicles, they're actually high performance vehicles. And in particular, not just Tesla, but Porsche just came out with a plug-in hybrid, BMW's coming out with more of a conventional car as well as a sports car. And a lot of these companies are making performance plug-in hybrids because of those performance benefits, not just for the environmental benefits. And just as far as well, okay, is it a right choice for your lifestyle? It's good to always point out, well, this vehicle only maybe has an 80-mile range, all electric. I'm gonna have to charge it again. The vast majority of people's driving in the country and here in Humboldt County is less than that per day. And so on the left hand is distribution of trips by how far you're going. So the bottom is like 1 to 5 miles up to 40 miles, and so you can see if this. I don't know if people in the back can see this. This is the 40-mile, trips 40 miles or less. As you can see, almost all the trips people are taking are 40 miles or less. I mean, there's only a few trips where, where people are actually going.
Who are those people?
They're going more than that?
No.
These are people inside of Humboldt.
This is Humboldt County, yeah.
To and from different places in Humboldt.
And we're not untypical for the rest of the country. It's pretty similar numbers, which is why when Nissan was saying, oh, what range do we need to put in the Nissan Leaf? They said, oh, if we got about 75 to 80 miles, we got all those people, and most people have 2 cars in a family, so this can be one of their vehicles, no problem. We don't need to do more batteries than that, and that was one of the reasons why that's really the target they look for, is that you can easily accommodate, a 30-mile commute back and forth to work. And this is just a similar graph kind of saying what percentage, 96% of trips in Humboldt are less than 35 miles, and so that's where even the plug-in hybrid options come in nicely, because if you're going, let's say you live in McKinleyville and commute to Eureka, you could have a Chevy Volt and get to Eureka and back and be in that 35 to 40 all-electric mode range and never have to use gas for your daily commute. And then, okay, that one time when you need to go out of the area, go to Garberville, then you've got that extended, hybrid capacity to go another 300, 400 miles and just fill up at a gas station when you need to. So, that's where even the plug-in hybrids can really, from an electric vehicle miles traveled standpoint, meet a lot of people's daily commuting needs without needing a ton of range. So as far as the state, there's all these benefits to electric vehicles from an environmental standpoint, from an economic standpoint. The state's really making a pretty concerted effort to push this forward, and folks may have seen the video, Who Killed the Electric Car? There's been kind of false starts for electric vehicles in the past. And so the state, I think, does not want to see that happen again. And so they've been working closely with auto manufacturers and setting policies that really drive that. So the governor set a goal of having 1.5 million zero-emission vehicles on the road by 2025. And so that includes electric vehicles as well as hydrogen fuel cell vehicles. And the hydrogen fuel cell vehicles are actually going to be ramping up quite a bit in California as well in the next couple of years, mostly around the Bay Area and Southern California, where there's fueling infrastructure, although we have fueling infrastructure up here. That's where they're looking to place the vehicles, and so we're going to be seeing a lot more fuel cell vehicles on the road as well, but the biggest share of that is going to be electric vehicles. And locally, they're basically our sort of share of that, if you look at our share of vehicles, is trying to get up to 5,000 or so vehicles in Humboldt County by 2025, so that we're contributing our share of that 1.5 million goal.
And Matthew, how does that compare to the penetrations that we were looking at earlier?
Yeah, so that's beyond that 25% more than hybrid range was getting up to about 3,000 vehicles on the road. So it's definitely a stretch goal, and that's where it's not just probably going to happen without some bit of oomph, and we'll talk about that. And again, just kind of hitting back on the environmental benefits. This is a rather daunting Sankey diagram, and so what on the left here is sort of primary energy use, and so this is where in Humboldt County, for homes, for heating, for transportation, all of our energy is coming from petroleum, natural gas, and biomass actually is a big chunk of it locally. A large chunk of that natural gas and that biomass is going to electricity, and so here's our electricity use for businesses, homes. There's the natural gas piece that goes to heating, and so that's kind of split. And then the petroleum, pretty much all goes to transportation. And so this chunk of our energy use is, dependent on petroleum. And so it's like, well, how do we start getting it into, ideally, this renewable section up here and out of this, high greenhouse gas intensity source here. And this also just kind of is another way to highlight. This shows the breakdown. This is what's actually moving the vehicle, and this is how much of that petroleum is just lost to your engine wasting heat. And so the majority of the energy in that gasoline is going to waste heat, which is why cars need radiators to keep them cool, because there's so much waste heat generated. And so if you look at this net petroleum input, you can see that's the biggest part of our greenhouse gas emissions. It's more than like 60% of our local greenhouse gas emissions is really the transportation sector. And so that's where, how do we actually address transportation, and electric vehicles are really kind of the key strategy in the short term to start. I mean, obviously, I should say, the best way to do that is to ride a bike or take the bus or walk, and that's always going to be the lowest greenhouse gas option. That's not always possible, and that's where, okay, besides those kinds of strategies, and don't want to minimize those are, should be your first pick whenever you have the chance. But for when we do need a vehicle, really electric vehicles in the short term are the key alternative option that's out there. As far as state policies to kind of help move these goals forward, that they're doing this readiness planning effort, and so the state has its own readiness plan that they're coming out with for statewide targets. They've done sort of various resources like a readiness guidebook that kind of provides guidance to local governments on how they can work with their communities to help make this successful. In particular, they've been funding these regional planning projects, one of which is our project. They're also putting out funding to put in infrastructure, and we'll talk a little bit about a proposal we put in and we're waiting to hear back about. But they're several, they've got $25 million out so far, and they've got another $30+ million in the works to actually start just helping get that infrastructure out there so that there is the charging infrastructure. And then they've got the Clean Vehicle Rebate Program, which offers rebates to people buying electric vehicles or plug-in hybrids or fuel cell vehicles. And so there's over $100 million that's been committed to that to help basically actually, when people are buying these vehicles, to give them a rebate check of a couple $1,000 to bring that cost down, since there is a bit of a cost differential, at least at the purchase price, this upfront cost, not necessarily the life cycle cost, but the vehicles are a little bit more expensive than their conventional counterparts, since they're a new technology. And so I'm going to pass it over to Colin. We've got the vehicles. That's kind of the vehicles are out there. They're getting on the roads. We want to support them. That's why Colin's going to talk about, well, okay, this is totally different than gas stations. What's the charging infrastructure, and then what do we need locally? And I'm going to pass off the mic.
Thanks. So chargers. So there are several different options when you want to charge an electric vehicle. And really the biggest difference between these is the rate at which you can charge your vehicle. So there's what's called level 1 charging. Did I do that?
Yeah.
How?
The right-hand button should do it, I think.
Oh, okay.
Yeah.
No, they're all zoomed in. Oh, this. Let's look at this screen. So it's referred to as level 1 charging, but this is just wall outlets that we have everywhere. So it's 120 volts. All modern EVs, you can either get an adapter or it comes with an adapter, and you can plug it right into the wall. It charges at a rate of about 4 or 5 miles of range per hour of charge that you get. I find this to be, for me, this is the most intuitive metric I have, so I can think about, well, if I wanted to go from here to there, it's about 20 miles, it's about 5 hours or 4 hours of charging. So level 2 is 240 volts, and this is the most common form of charging for people when they purchase a charger to install in their garage. So any residential service panel, electricity panel, you can get 240 volts out of it, and they connect that up to your charger, and then it goes to your car. And these, depending on your vehicle, they'll charge you up at a rate of 10 to 60 miles per hour of charge, with 20 miles per hour being the most common rate at which vehicles are charging right now. But any level 2 charger has the capacity, well, not any level 2 charger, the level 2 standard has the capacity to go up to 60 miles. It's just that the vehicles, the onboard chargers in the vehicles haven't really taken the step to charge at that rate yet, probably because of battery management issues. The faster you charge, the shorter the life of your battery. Then there's one step above that, which is level 3 or DC fast charging. The biggest difference here is you're charging using direct current. You're directly connected to the batteries, and the voltage is even higher. It's 400 volts or even higher than that. The rate at which you're charging here is anywhere from 90 to 300 miles per hour of charge. So if you're charging a Leaf, which has about 70 miles of range, you're definitely going to charge it in less than an hour, potentially as fast as 15, 20 minutes. One limitation to the DC fast charge is it can charge really fast until you hit about 80% of the battery's state of charge, and then it reduces the rate of charge down to the level 2 rate. And that is, again, to save the battery so the battery doesn't overheat, and if you put too much current into the battery when it's at a high state of charge, you can start to degrade the batteries. And then finally, it's worth mentioning that there is a viable alternative to charging, which is doing battery swapping. Now, there was a company that went out of business trying to make this their entire business model. But at the same time, there's another company, notably Tesla, who already has built and delivered vehicles, the Model S, which is capable of battery swapping, and they've built battery swapping stations throughout the nation. So when you do a battery swap, you're effectively charging your vehicle at a rate of 10,000 miles per hour of charge. Now, you wouldn't actually, it takes a minute, and that's all it takes, and you're done. It's comparable to filling from a gasoline pump, which the rate of delivery of miles to your vehicle is about 15,000 miles per hour of pumping at a gasoline pump. So battery swapping, if all you care about is how quickly you can get the energy into your vehicle, battery swapping is actually totally competitive with gasoline pumping.
Colin, do you know,
Yep.
when you say that Tesla has stations, battery swap stations throughout the country, do you know how many they have?
I don't know.
Probably pretty few at this point, but, or...
Yeah, I don't know. I know that they have their DC fast chargers. They have a network throughout the nation. They probably have 20 or 30. And the plan is to have battery swapping stations at each of those. I just don't know how far along they are in that process.
They're building that supercharger network really quickly here and in Europe. And I saw recently this video on the Tesla site with Elon Musk bragging, and they do like a race. He swaps out 2 Tesla Model S battery setups in the time it takes somebody that's linked in to fill up their gas.
Right.
And his whole pitch is the superchargers are free and always will be. So it's your choice of whether you want fast or free, and that's their marketing.
Right. Yeah. So their level 3 DC fast chargers are free to Tesla owners, but you have to pay $50 per swap to do a fast swap.
And they're not available to anybody else with an electric vehicle. That's kind of the downside to it in terms of
Right.
promoting vehicles other than Tesla.
I think the level 2 charging is available to other people, but
They haven't developed an adapter yet for Tesla chargers.
So it's my understanding that there are adapters so that a person with a Tesla vehicle can charge at any regular station.
Get a chat on.
But right. But the other way around, I actually think that the chargers and the control system on the charger itself won't interface with a Leaf, for example. That's my understanding. And that has to do with the fact that they're providing this premium service free for people. And suffice it to say, to me, it shows that at least battery swapping seems like it could be a viable alternative here. Maybe eventually it'll become more accessible. But
$50 to swap your battery, is that what you're saying?
Right. But people pay $50 all the time to fill up their engine with gasoline. So it's more expensive than just buying the electricity. You're right.
So that's not something you have to do all the time. It would be on occasion if you're on a long road
Right.
trip, and you don't want to waste the 45 minutes going up here.
Right.
It's kind of crazy though, because there's so much value in that battery that you get with your car when you buy your car.
Right.
And then now you swap it out with this other battery, which is most of the value of your car, and now you're off maybe down to the next state with it, and your
Right.
battery's back at that swap station. The health of the batteries compared to each other, how
You don't own the battery. Basically, with a Model S, you don't own the battery. You're sort of leasing it. And I don't know legally how that works, but effectively, that's what's happening if you if you use the battery swapping.
I mean, yeah, from a lease concept, it'd be a different, right? It's just like
Yeah,
leasing a car.
if you're leasing the battery, right? But I
It's
think-
their problem if the battery wears out, they gotta give you a new one that works well as part of the
Right,
lease.
but I know there are people that have bought Model S's with the,
It
because
owns
you
the
can,
battery.
you buy the whole car, you can choose what your capacity is, whether you want the big battery pack or the
Right.
small battery pack.
Mhm.
Say I chose the one with the big battery pack, and now I wanna go out and tour the US, and gee, it'd be cool to try that battery swap station. I don't know, to me, it's just, I'm sure they quality control it, but it just, it's,
Yeah.
Right.
there's so much value in that.
And battery swapping takes this coupling of the manufacturers have to produce cars that are compatible with the stations. And so it's not easy, and it would be very difficult to have battery swapping capabilities that were cross-compatible across different manufacturers. So it's become somewhat, there's somewhat of a consensus out in the industry and amongst policymakers and academics that there's sort of a loading order here. There's a priority in terms of the number of chargers that we really need out there in the world and which ones sort of rank higher than the others. And the most important are the residential chargers. As we were saying, with those plots of the length of trips that people take, I mean, for the most part, most of our travel we can do on a single charge and then just plug in when you get home, and it's ready for you to do it again the next day. After that would be the workplace charging or fleet charging applications, because there it's a little bit more predictable how many people are going to use the chargers and how often, and it's going to be pretty consistent, and it's pretty easy for employers to know how many chargers they need and to use that as a perk for their employees, or not. They could charge their employees to use them too. And then finally at the top would be public chargers. And the pyramid also symbolizes not just rank or importance, but also the number of chargers that we expect to need out in the world. There are going to be basically one of these for every vehicle, and a fewer number of these and the fewest number of these. We actually don't need that many chargers to be out in the public space in order to reliably serve people's needs as EV drivers.
Well, one thing that for us locally to consider also is that, unlike Silicon Valley, where there's going to be a Google campus and they can say, oh, we've got X number of employees that have EVs, locally, with the exception of maybe HSU and a few places, workplaces typically are also public parking lots. We have a lot of city-owned lots and on-street parking. We don't have as many businesses that this is our employee parking area where we're going to put in designated, charging for our employees. And actually, as far as it's surprising that you think, oh, someone's not going to buy an electric vehicle unless they can actually charge, in their garage. But there's actually at least one person locally who lives in an apartment in Old Town. They bought a Nissan Leaf, and so they're dependent on public charging opportunities to charge their vehicle. And so they just said, nope, we're going to do it anyway, and we're just going to use the public charging infrastructures.
Yeah, there was a recent survey of all California, well, not of all drivers, but of drivers in California, and something like 96% of people who own an EV have a charger at home, but there are, about 1 in 20 people don't. And it's worth mentioning that there are already about 7 public charging locations in Humboldt County in these cities. Yeah.
Does HSU have
HSU does not, but HSU is planning on installing some. It's just a matter of when and where.
HSU has level 1 charging, but it's not intentional. People take an extension cord and plug into an outlet that they find through a window or something. But
Yeah.
we're trying to work with HSU and the facilities people here, Tracy Fertilage and others that's on their radar screen. They want to get that infrastructure started to be put in, but it hasn't happened yet.
Does that Redwood charger really exist?
Yes. Yes.
AE Solar down there put one in, so they've got an outlet, and they put in like a standard.
It doesn't show up in plug share anymore.
Yeah, and I
Oh, really?
That's one of the things that we're actually going to work on getting that to show up on, because it's not on a couple of the web pages, but it is down there.
Yeah, I'm thinking about getting an electric Leaf in the next few weeks, and getting it back up here might be a problem if there's not one in Redway, or I can stop at Benville maybe, but.
Right. Yeah, the Benbow Inn lets people use their RV charger.
That other than north of Ukiah is pretty
Yes, the gap there.
So how do you use an electrical charger?
You need an adapter, but it's
So we've got our thing that plugs in at home. It just plugs into a 3-prong 240 or whatever. You go with an adapter.
you can do it either way, but most people install the chargers because the chargers have some smarts in them, and those use what's called the J1772 plug, which doesn't look like a regular 240 outlet or plug. But you can get an adapter, and you can actually plug in to any standard 240 NEMA outlet.
Coming off your car.
What's that?
Coming off your car with that.
Yeah.
Yes,
I-
there are people that convert those, the unit that comes with the Nissan Leaf that you have in your suitcase in the back.
Yeah, but that goes just into the wall. So.
Yeah, but there's people that will convert that to take 240.
Oh, okay.
And then from there, you take, and you can gin up a plug that'll go into the RV pedestal, any 50 amp RV pedestal. So you just have to look online for somebody who's converting those, and they cost about $700.
To convert you to.
You can send them the one that you have in your car, and they'll convert it, or they can sell you one that they've already converted.
Yeah.
What's DC level 2? Because you talked about just DC, but is that just not supposed to be there, or?
Huh.
Under
Oh, well. Yeah, there is no, when it says DC, it's referring to DC fast charging. I think it should be like DC comma level 1, DC comma level 1 to 2. So they're separate things. So DC is the level 3. It's the DC fast charger. It's the superchargers.
There's not anything. I don't see those listed on your.
Up at the top is where they're. Is this where you're referring to? No? Oh, here? Yeah, here too.
Report from like the state, and I think they also were talking about, because there's a range of, you can have different levels of DC fast charging. I mean, it's not all, people don't usually refer to it. I haven't heard them use that term. It's just kind of a nice illustration, but there's not like one amount of, kilowatts per hour DC level, so it's, I think, pretty good at that.
Okay. All right. We should move on. So I'm going to go through in a little bit more specificity some of the work that we've done, some of the results that we've come up with when doing the North Coast PEV work. So the main activities we've been doing is coming up with this infrastructure plan. Where are we going to put chargers? What type? How many? We've looked into efforts to streamline permitting and the installation and inspection process, both for residential and for public charging. We've done some fleet evaluations, looking at the opportunities to replace conventional vehicles with electric in regional fleets. And then we've done some education and outreach activity. So thinking about the charging infrastructure plan, without going into a great amount of detail, our approach here was to develop a simulation model that lets us simulate individual drivers, electric vehicle drivers, or plug-in hybrid drivers, navigating throughout the county, going about their daily business. And then if they need a charge, they stop and look for an available charger. And if they find an available charger, they plug in and start charging. Sorry, I have to go to a different place in order to get the animation to run. This just gives you a visualization that gives you an idea of what happens. So over the course of a single day, these little black dots are the people moving along the roads. And then when you see the green or the blue circles, that's people who've plugged in and are charging. The idea here is we can then, when we simulate these people doing this, there are multiple people at times competing for limited charging, and we can tell if somebody walks up to a charger and can't because someone else is using it, and we can tell if somebody is delayed because they don't have enough charge to get where they need to go, and they have to wait around for the charger to open up and become available. So at the end of the model run, we sum up all of the delay that occurred throughout the whole model run. That becomes our metric for how much inconvenience are people experiencing. And then we play around with where we put the chargers, and we vary the number of chargers, whether they're level 2, level 3, throughout the county, and we use that to ultimately come to what we've estimated as an appropriate number of chargers spread out throughout the county in order to serve the needs of the expected number of drivers. And in this case, we were targeting this 2% penetration, or 3,000 drivers. So, these are just general guidelines, but they give you an idea of the distribution of chargers that seems like what we need, right? So most of the chargers are sort of concentrated around the population centers around the Humboldt Bay, but then there are chargers all along the 101 corridor. There are several chargers needed out in Willow Creek because the distance here is just far enough and there's enough traffic going back and forth that it makes a lot of sense to get some chargers out here, including a DC fast charger, in order to allow people to make those kinds of trips. And a DC fast charger would also be helpful in giving us some regional connectivity between Humboldt and Trinity and Shasta County. Right, right.
There are a fair number of people, yours truly, that commute back to Crescent City. And I want to get to Crescent City.
Mm-hmm.
I can't get to work on stuff to even do about the food charger in Klamath.
Mm-hmm. And I'll say that our...
The guy at Nissan place that sold me this car said, oh yeah, no problem, we can get it. It's got a 115-mile range. No problem, we can get it to Crescent City.
Yeah.
Is it perfectly flat between here and there? Because it would work.
Don't turn on the heater.
I guess electric car dealers are like regular car dealers.
I will say that this part of the analysis was Humboldt-centric, but this entire project did take into account Del Norte, and so we did come up with some recommendations for the number of chargers that would make sense up in Del Norte as well.
You put a DC in Klamath?
That would be, well, so you see, our model was just Humboldt, so it basically ends.
I'm actually talking to a company that was looking at maybe putting a DC fast charger in. They were looking at a potential grant opportunity for that, and they're putting one in up in Brookings, I think, right now, as part of Oregon's network, which has done a lot of that. And actually, it's kind of a neat, because the problem is you're going to have pretty high power service to be able to supply a DC fast charger, but they're using a system where they put in solar and storage, and so they can have less electrical service on site, and then they can basically use the battery storage to kick that up to enough to do DC fast charging. And so they were hoping to basically, because they're working with the Oregon folks, and they wanted to have that connection so you could be coming down the Oregon coast from Brookings, get down to Oreg or Klamath or somewhere, and then potentially, connect down here and or, up 199. So they were looking at the Klamath, Crescent City kind of loop back to Grants Pass.
And we actually just learned today that the Oregon Department of Transportation is actually planning to add charging all along the 101?
Yeah,
the coastal highway on Oregon. And so they're going to be very interested to see us on the North Coast do something similar so that there's connectivity between us and Oregon.
And we, while the modeling for this project is basically done, we have sort of the modeling results, but the final guidelines that we're putting together and will be submitted as our final report and kind of be the guiding document is actually not finalized yet. So we can take your input as we could add some DC fast charging along the 101 corridor to Highway 1 as well.
I bought this car thinking I'd like to get back to the same system as well.
Well, yes.
Is that modeling going on as well to get us out of Humboldt County with our electric vehicles?
If what you're interested in is enabling connectivity between regions, you don't really need to do this kind of modeling analysis. It's just about the distance between the chargers, right, and making sure that you have enough of them along the way. And there is interest in doing that, and we do know that Mendocino is interested in that. They actually funded their own study. They didn't get funding from the CEC. They put down money to have a consultant do a similar sort of study, but it was smaller in scope. The only other take-home message from this that's important is that this represents about 50 chargers throughout the county. 50 chargers for 3,000 drivers. So, we're not talking about huge investments in infrastructure. Again, remember, every one of these drivers, at least the assumption that we made in the model was that all of these drivers had a home charger. So we already have 3,000 chargers distributed throughout the county. What do you need more in order to really just accommodate those few people, 5 to 10% of people who take trips that exceed the range of a Leaf? Okay, so lastly, I'll just mention, and we're going to go into this in a little bit more detail, that this was this macro scale analysis where we're just thinking about the broad brush, where do we see infrastructure being needed and how much. But we, and when I say we, it was really Dave Carter, went to great lengths to actually go and scope out individual parking lots throughout the county, dozens of them, and really take a close look at which specific sites make the most sense for the first fleet of chargers that we actually install throughout the county. So we'll get into that in just a second. When thinking about the micro-siting, about where to actually site chargers, here are some of the important things that we need to consider. Access to an electric panel is obviously important in order to deliver electricity to something. The capacity of that panel is important because these chargers charge at a pretty high rate. It's beyond what most appliances consume. We're talking 6 kilowatts or as much as 20 kilowatts, depending on the vehicle. Accessibility, when you're putting this in a public parking lot, the very first charger has to be placed at a location where you have a parking stall that it doesn't have to be striped blue, but it has to be compliant in terms of its dimensions with the American Disabilities Act, so it needs to be wheelchair accessible. And then we have to think about how accessible the charger is to stalls. So ideally, you would place a charger in a location where the cord can reach vehicles in multiple stalls. That way you can have multiple people parking, and when one person's done, another person can walk up and just move the cord to their vehicle. And then methods of payment. The state of California is actually requiring, when the state funds EV charging, they're requiring that the systems allow you to swipe a credit card or wave a credit card, as the case may be.
An interesting thought on your comment that I heard. I was just down at a meeting in Sacramento on the number of spaces you need per location. And a lot of our efforts and a lot of folks were like, we don't want to overbuild this and have all these empty, electric vehicle spaces sitting there because it makes it look like it's not happening and it makes it look kind of dead and like a failure. They've been actually, in most places, experiencing the exact opposite of that, where some business will put in 10 chargers and they'll have 20 employees with electric vehicles. Or a guy showed up to the meeting and he was like, yeah, I pulled into this parking garage and there was 10 spaces and every single one of them was taken. And so he had to come back later and wait for one to open up. And so people have actually been starting to talk about charger rage, where people can't find a charger or someone that doesn't need to be charging is in the space and competing for these spaces. And so it's funny, so many people were worried about the stranded, underutilized infrastructure, and it's actually ended up being that they're not building it out fast enough for the demand, because the demand's been going faster than what was anticipated.
Is the plug-in thing for level 2 charges, are they universally the same for all models?
Yes.
Yeah.
Including Tesla?
No, that's the one exception.
But BMW, Toyota,
Yeah.
Nissan, they're all got those same ones?
Yeah, the Society of Automotive Engineers came up with that standard and all this. So Ford, Toyota, Honda, everyone except for Tesla's kind of doing their own thing, but all the other conventional Mitsubishi, they're all using the same connector.
Even though this home charger as well that I bought seemed to somehow come via Nissan.
Yeah, they brand them, so Ford has one that has a Ford logo on it and things like that, but it's all the same connector, so they're
My
interchangeable.
friends come over, plug into mine just as well.
And that was an effort to, some of those earlier EV efforts, these guys have these paddle chargers, and these ones have this other kind of approach, and these ones have inductive where you park over it like your electric toothbrush, and and so they really wanted to make sure that there wasn't, we got to have a charger for these guys and these guys and these guys, and so they worked together over a couple years so that all the big companies said, all right, we're going to use the same standard so that no matter what charger you go to, you can plug in.
Is
Right.
level 3 is going to be the same as well? I've heard of Chatamo, which is the thing for Nissan, but what about the other EVs that are coming out over the next couple of years?
Yeah, they have the CHAdeMO, and then they have the J1772 combo plug, which like the Chevy Spark has that, and that's probably the one we're going to see more of. It looks like a J1772 level 2 plug, but it has these two big prongs under it.
Oh, yeah.
That, so you can do both level 2 and level 3 through the same plug. And so the question is, are we gonna build a retrofit CHAdeMO stations with that cord, or maybe provide 2 cords on there?
It's
so
important
that-
consideration as Chad was, I mean, those level 3 stations are extremely expensive.
Yes. Yeah, it's,
Multiple kinds of vehicles.
yeah.
Unless you're Tesla and it's part of your model vehicle to buy your car.
Yeah, it sounds like it's Tesla and everything else.
Right. Tesla's kind of the Apple of the manufacturers right now. They're trying to create a walled garden. Okay, so this is somewhat redundant of what Matthew presented earlier, but I find this really interesting. So this is a comparison of the emissions profile of a conventional vehicle versus an electric vehicle, and these we're looking at upstream emissions and tailpipe emissions. So a tailpipe emissions for an EV is 0 because it isn't emitting anything out of its tailpipe, and then here are the tailpipe emissions for a conventional vehicle. Here are all the emissions associated for the wells to tank, right? This is processing, extracting the petroleum and transporting it to your gas station. All of those emissions are greater than all of the emissions associated with producing the electricity that you put into your battery. So,
And that's in California, is that right? California?
yes, this is a California-centric.
West Virginia looks different.
Yes, it looks different. Still, it still beats out the. In most cases, it's going to. This is a conventional vehicle, 25 miles per gallon. So, this just drives home the point that it's not only it not only might save you money, but you're making a huge impact on your own personal carbon footprint by going to EV if you can manage it, if you can afford it.
Same analysis, including the embedded energy in the battery and that kind of stuff?
We did not do that analysis, but I looked it up because someone asked us on the radio about it. And so afterwards I looked it up, and indeed there is a little bit more embodied carbon in an EV than in a conventional vehicle, but over the lifetime of the vehicle, this difference, I mean, it far outweighs it. So I don't have that plot to show you. You can find it easily with a Google search.
One concern that I have about this burgeoning industry and demand for electric vehicles is how will our grid support it, and are we creating an irreversible reliance on
There's a slide for that.
The next slide. So this is somewhat a different question than that, but I can tell you this, that we did a study before this one that was looking at all of Humboldt County. It was looking at all of our renewable energy opportunities, and it was also looking at, well, what if we developed renewables and we switched a whole bunch of vehicles, 40% of our vehicles we got up to, over to EVs, and no problem. It's a substantial amount of energy, but it's not going to overwhelm our grid. It's not more energy than we're already consuming in terms of just the total capacity. So it would require adding some capacity. It's going to require doing some upgrades to the grid, but it's not as much as you might think. And this is looking at a question that had a lot of people concerned, which was, well, but okay, so maybe the grid can deliver that amount of energy, but what about the peaks, right? Because the peak is when you get the big problems on the grid and when things get really expensive. So we did a peak analysis for Humboldt County. This is just showing a bunch of different distribution circuits. So the distribution circuit is what's in between the transformer outside your house and the substation, right? So it's all the poles that run through your neighborhood and carry those wires. So a bunch of different distribution circuits throughout the county. The blue part of this bar represents the peak that is existing naturally just from people coming home and turning on the lights, because in Humboldt County, our peak is in the winter, in the mid-evening when people all get home and turn on their appliances and lights. So the blue is the peak that is existing, and then the orange slivers is how much we're going to add to that peak by people also plugging in their electric vehicles if we had 2% penetration, 3,000 vehicles distributed throughout the county. So it's tiny. You can barely even see it in some cases. And the gray is just showing how much capacity is left on these circuits throughout Humboldt County. And they're sort of ranked in terms of the, Garberville 1103, is sort of the one that is closest to being maxed out. And then, this one on this end is the least close to being maxed out. So
it's not how much juice the wires, the circuits can carry, not
yes, right. This is the sort of instantaneous.
unless you're pulling it off, it's not being used, the energy is, or is it? Is the energy just there and it's not used as wasted?
Oh, you mean the gray, the capacity? Yeah, that's it's like the size of the pipe, right? At some point, you can't push any more electricity through the pipes. And so at some point, they overheat is really what happens. OK, so this is not a problem for us. It might become a problem for other places in the state in the next 5 to 10 years. Now, once we get beyond 5 to 10 years from now, it will be a part of the consideration, but it's not something that we need to worry about in the near term. And we know from discussing this with people at PG&E that they're not worried about it, even in the Bay Area. OK. I'm going to have to speed up a little bit so we have some more time for discussion, although we've been engaged in discussion all along. So another component to this work was doing fleet evaluations. And Jim, with the help of a student, Allison Campbell, developed a tool, a spreadsheet tool that they used, interacted with people who manage fleets around the county. They did a couple, I think the city of Arcata and the city of Eureka. And the idea of the tool is just to give someone the ability to characterize how they use their vehicles. How many miles do they drive in a day on average? What's the maximum trip that they need to be able to drive? And then how many vehicles they operate, et cetera. And then select from different drop-downs the different types of vehicles that they might consider buying. And so look at, well, what if we bought just a conventional Honda Accord? And what if we bought a Leaf? And what if we bought a plug-in hybrid? And then, the spreadsheet is designed to calculate for them, the difference in the upfront cost, the difference in the cost of ownership, the life cycle cost, the greenhouse gas impacts, et cetera, the simple payback. And it turns out that especially if you have vehicles that get used a lot, you can get some very low paybacks where you pay a little bit more up front to get that EV, but it pays itself off within a couple of years in terms of reduced fuel costs. So this is, using EVs actually makes a lot of sense in fleets, especially if they get a high utilization, but they don't need to take, they don't drive more than the range of the vehicle in a day. Anything else? So the biggest PhD went and looked at parking lots in all these places and evaluated them according to a whole bunch of different criteria and used that to rank the sites and to select the ultimate one that we wanted to propose to the CEC. And I'll just show you a couple examples of specific sites and what they look like. This is the Trinidad Library, which is very close to the gas station that you first encounter when you get off the highway in Trinidad. You can see these are the engineering drawings that GHD came up with showing where this laser's not working anymore, where the charger will actually be. This is the charger we're proposing in Willow Creek, actually at the Bigfoot Museum. And then we were proposing 2 chargers at St. Joe's Hospital at the new or just in the parking lot right next to the new facility.
For staff, for public use?
These would be public chargers, yeah.
But they have staff that have been asking for it, so it would be both. And that's, again, one of those sites where you're like, oh, okay, you don't want to just put in one and then have 3 people that work there and then somebody from the public show up and then you've got 4 people waiting for one spot. And so trying to kind of anticipate that. And that's
How
what
time for charges you anticipate?
by the hour, I guess.
Well, so the operator of the charger has the choice to charge people by the hour or by the kilowatt hour. And there are pluses and minuses really to both of those. But I would say the longest someone would take at one of these chargers would be 5 or 6 hours. But most people, it'll be more like 1 to 2 hours.
That's assuming they come right back and move their car.
Get the car.
Right. And that's why it's really important to site these in a place where there are multiple stalls that can access them. Ideally, you can stripe them green and say that they're for EVs only. If it's a problem, so there's a balancing act here, because at the same time, you don't want to take spots away from people driving conventional vehicles, especially if it's a parking lot like on campus here where, they're a valuable commodity. So, just for the sake of time, I'm not going through all the other sites, but there were 6 other sites in our proposal. So the business model for this is that RCEA is going to be the owner and operator of the network. And this has several benefits to it. I think the biggest one is the fact that we can take a little bit more of an enlightened approach to siting these chargers. Siting some of these chargers, if you recall the map, in the more remote areas of the county, are really important, it turns out, when it comes to delivering the service to EV drivers, enabling people to get about, right, throughout the region. But they're going to get low utilization, which means that the revenues from those chargers are going to be low. And we can offset those by siting chargers both in the remote, low utilization places as well as in the more densely populated, high utilization places like St. Joe's or HSU, where we expect to have really high rates of utilization. If we have a single owner of the whole network, we can do that. Also, there's economies of scale. We're going to reduce the cost of operating them and servicing them and just the know-how of how they work. And then finally, RCEA is a nonprofit. And its board is governed by elected members of the public who are accountable to the public. So the next steps, as we see them in the next year or two, is going to be to actually begin installing in chargers. We're going to collect data on these, how they're used, and use that to inform where we site the next set of chargers. And then we're going to continue our work with municipalities and education and outreach. And then coming up this Saturday is an EV ride and drive at the Redwood Acres Raceway. There are going to be several different local dealers bringing EVs and plug-in hybrids, as well as a couple of electric bikes are going to be there and available for people to test drive, as well as just kick the tires and check them out. Do you have anything else you want to say about that?
Yes, it's a free event. It's open to the public. It's this Saturday. Come on down and you can take a spin around the racetrack and test out some of these vehicles, because that's, it's nice to talk about all this stuff, but ultimately, getting inside one and trying it out and seeing them in the real world is kind of, what's gonna make the difference for people to actually say, oh, I'd like one of these, and getting to actually experience it. So we're doing this one, and we're hoping to, maybe we'll see how successful it is, and we might do more. But certainly across the country, people have said that that's really the way to help people learn about these. But I would also add that, if you can't make it on Saturday, you can always stop by Harper Ford or Mid-City or, Opie's or, McRae Nissan and see what they have on the lot and test drive it. And, the vehicles are there. They're not, some mythical equipment. They're for sale now, so. And then we thought it would be appropriate just to mention here that the Redwood Coast Energy Authority, in partnership with other agencies throughout the region, recently got awarded another grant from the California Energy Commission to do a very similar study to this electric vehicle planning study, but it's broader in scope. It's looking at all alternative fuels. So that would be hydrogen and biofuels and electricity, and yes, even compressed natural gas counts in this context as an alternative fuel. But it's going to be a similar sort of study looking at, what would we need to do in order to really promote the adoption of alternative fuel vehicles in our region. And then the Schatz Energy Research Center partnered with UC Berkeley and some others, Lawrence Berkeley National Labs, to form a Center for Alternative Fuels and Advanced Vehicle Technology. And this was a grant opportunity from
the California Energy Commission, and we applied for that and we got that, so now we have this designation as being a part of the Center for Alternative Fuels and Advanced Vehicles, which will give us a platform to continue this kind of work into the future, and give us some partners with people in the Bay Area to collaborate and share our findings and skills and whatnot. And wanted to make sure that we at least got some names up on the board, because this effort has involved a lot of hard work from a lot of different people in a lot of different capacities. And something that I don't think we mentioned was that all along this process, we at the beginning we formed what we called the Plug-in Electric Vehicle Coordinating Committee, and this was just a bunch of regional stakeholders, people from municipal governments and other PG&E and other agencies, all sort of served as sort of a board or a guiding committee to review the work that we were doing, give input, and also just learn about the results of the work. I think that's it. Thanks.
These public charging stations, how would it be assessed? Would it be assessed by the amount of time that you have it on in the car, or just once the car is charged?
It can be done either way. I mean, so different locations have been doing it different ways across the state. I think, I kind of favor charging for the amount of electricity you use, because that's sort of a more straightforward way, especially since different cars charge at different rates. And so one person might be there for an hour and use half the electricity that another person's using in the same hour just because of which vehicle they have. And so kind of probably the fairest way to do it is to use the amount of electricity that you can charge. It was not originally, there were some concerns about that, about becoming a power reseller based off of what laws about reselling electricity, and that's been sort of resolved. So people have the option of doing either. The city of Eureka had set their pricing at just $1 an hour when they first put it in, just kind of as a simple way to do it. And for the short term, there's two that went in that we were working with the city of Arcata and GHD that put them in. We said, well, we'll just set it at the same rate as Eureka to be consistent. But I think we want to move that to more of a however many cents per kilowatt hour rate to charge for that. I think the flip side of that is potentially having time limits. So somebody isn't parked there for 10 hours and they only needed to be there for an hour. So you say, okay, it's it's a 2-hour parking space or it's in a 2-hour lot. So charge up for a bit and then move on. Because that's one of the issues, like I said, that they've been having in other areas where somebody might, oh, I've got an EV, and they'll come and they just want the parking space, and they'll park there, and they're not really using the charger. Maybe they're not even plugged into it, and somebody who actually really needs to use it isn't able to access it. And so, that's just one of the challenges of having these kind of hitching posts around the community, where you want to make sure that you're not, overbuilding, but also making sure that people are able to use what's there effectively.
You talked about the sort of urban charging needing to, in effect, sort of subsidize more rural and lower usage chargers. Did you take into account, is everybody assumed to be equally likely to purchase an electric vehicle? And are those 3,000 just distributed by demographics, or there's like an economic factor?
So for Humboldt, we had data on vehicle registrations, and we looked at where people have registered hybrids over the last 10 years. And then we assumed that EVs would follow a similar spatial distribution. And so that influences where the vehicles drive around in the simulation analysis. And so yeah, that's another reason why some of these chargers in the outskirts don't get used as much, is there are fewer people who own vehicles out there.
Do you have a feel what charger density per EV looks like compared to pump density per typical car? Would that come up at all in the model?
I don't have the numbers in my head. We've thought about that. Unfortunately, and that's a great analogy if you're thinking about citing hydrogen fueling infrastructure or biofuel infrastructure. But for electric vehicle charging infrastructure, it's just such a different beast that it's almost not relevant, the difference between them.
Again, most of the charging is done at home, so it's
Right.
a very different situation.
The sort of inter-regional like DC fast charging is the closest where you say, okay, if we have X number of people that are going to be going from here to Crescent City or from here to the Bay Area, and we're putting in DC fast charging, some locations they said, oh, we actually had to put in 2 or 3 in this spot because there was such a number, a large volume of traffic making this longer commute. But for the level 2 charging, it is much more like a hitching post kind of situation where it's like, oh, okay, somebody's not going to stop there specifically to charge. It's more sort of incidental. But again, 80 to 90% of the charging is like your cell phone. You're not going to a cell phone charging station. You're just coming home, plugging it in, and then coming back, in the morning and grabbing it when you need to go. And so, it's a different sort of mindset. But the DC fast charging is where they do kind of look at, okay, how much do we actually need on this corridor to accommodate that traffic.
I mean, the other thing about that, I think, is that an electric vehicle charging station can be one unit, that's really serving a very small number of vehicles on it for any given day, whereas a gasoline station serves a lot of vehicles coming through because it doesn't take very long for them to fill up. So you don't have very many of them around, but they serve a large portion of the population.
Especially for plug-in hybrids, like if you got a Volt or a plug-in Prius, you don't really even need the level 2 charger. You just, there's a charging station right there, there's another one right there, and you can get your full charge of your 20 to 30 miles just at night, even just at 120 volts, and so there isn't even a need for you to install that in your garage, and you can just, not worry about it.
I was just wondering about like a waste management perspective on like what you're going to be doing with the batteries, or what's going to happen to batteries when they no longer have the capacity that they originally had, and people are looking for new ones. And so, did you guys come across any of the information on that, or what exactly are the steps and procedures for dealing with that essential waste product?
The various folks have been looking at that, and there's a few different pieces of that. I think the states actually had some funding opportunities, and maybe the federal government as well, I believe, in addition to doing their own research, and around places like that, of looking at, hey, let's look for like business opportunities or recycling opportunities for this. And a big part of that is that a battery might not be so great for a car. A car's a pretty high demand thing. It's like, oh, I want it to be instantly on, and I need to be able to slam on the gas, and I want to have lots of capacity, and so a battery might be a perfectly decent battery, but it's lost 30% or 40% of its capacity, so it's not really performing up to the standards that you need for a rigorous car use environment. But it's still a perfectly decent battery, and so I know they're looking at a lot of sort of secondary applications where maybe grid stability, where you're saying, oh, okay, let's take a big bank of these in some place where we have issues with peak demand or at a facility and use it for energy storage, so we're charging them up when there's excess electricity generation, and then there's a peak pricing situation, and we can use that to mitigate those kind of load strains. And so I think PG&E and others are kind of looking at sort of in the early stages now, because it's not really a big issue at this point. We're kind of looking down the road. Oh, what are we going to do with thousands of these batteries once they're kind of somewhat spent, and they still have applications in those kind of more stationary applications where you're not having to have a lot of density. That you can have as much space as you want if you're putting it in a warehouse as opposed to trying to fit it into a car.
And if you've heard about Tesla's Giga battery factory that they are planning, battery recycling is integrated into that factory. It's a part of their plan. So,
have you guys looked into the worldwide lithium supply for lithium batteries? Do you know what the answer is to that?
Yeah, the answer that I've heard, and I haven't heard this recently, but is it's not a problem. There's plenty of lithium.
There's enough lithium in the salt flats in Bolivia to get us to the next.
Yeah. But it might not be, 50 years from now, who knows? I mean, if we're really talking about every vehicle on the road being an electric vehicle, it might start to become a strain on that resource. I don't know.
Might be some other technology.
Yeah,
right. Well, there certainly will be.
It's not just cars, thanks to these things and laptop computers, that there's a lot of people interested in batteries and evolving battery technology. And so, by the time it starts to be an issue, it might be an obsolete technology. Someone's going to have a way better battery option by then. So,
And I know some people that are going to be driving fuel cell vehicles.
Yes.
Some people are partial.
So in
Well, they want batteries,
the,
but not as many or big as the battery bank.
In the plots you had where you were comparing adoption of hybrid electric vehicles and then currently EVs, is there any information about who those people are and whether the same people that were the early adopters of the HEVs are also early adopters? They just switched technology to EVs?
I think that's available. So as part of the rebate program that the state has, they have a survey that they, it's voluntary, but people fill out a survey. But thanks to that survey, they have a pretty robust data set of, who are these people that have a second car, what's their level of education, trying to get a handle on that question. I don't remember the specific, if they asked, did you have a, I think they do certainly ask, do you have another vehicle, do you have one vehicle? But I don't know if they asked, did you already have a hybrid, or are you trading this in for a hybrid? I know sort of anecdotally, we've talked to local drivers and said, oh, I had a Prius, and then we just, upgraded to a plug-in Prius because we wanted to be able to have that option. So
It was such an aggressive adoption curve. One thing that I thought of is that maybe there's a limited market. A lot of curves rise up very steeply and then they plateau. The hybrid curve hasn't plateaued, is that right? It's still rising up? Or is it?
I think it's at about 10. Am I right here? No. It's like several percent penetration into the national vehicle fleet.
But it's still on an exponential plot or at least a linear plot?
Well, I couldn't characterize the curve, but yeah, it's still increasing.
But it's a good point, and that's one of the things that people bring up is like, yeah, hybrids have done well, but there's still a small percentage of the overall vehicle population. So if we're really talking about, how are we going to get an 80% reduction in greenhouse gas emissions? It's going to have to be more than just saying, well, if we can keep up with hybrids, that'll do it. So it's going to take multiple strategies beyond just vehicles, of course. But certainly, I think looking at, okay, it's going to have to be a dramatically different uptake. And I think the one strength of that is when you start looking at the equivalent of $1 to $2 a gallon for gas, people can start quickly doing the math and saying, I think I'll consider that.
You mentioned the Mendocino study earlier. Do you have any more information like the year it was done or whose contract?
Last year when they did it, and it was the Mendocino County of Governments.
Yeah, Janet Worth at the Mendocino Council of Governments. Janet Worth, O-R-T-H.
Yeah, it's on their webpage, I think.
She's with the Mendocino Council of Governments.
Right.
Which is like, we've got the Humboldt County Association of Governments, which is like, they're both government joint powers authorities similar to us, but they do the transportation planning for their counties. And so MCOG is the one that did the Mendocino study.
Yeah.
Yeah, you looked into partnering with somebody like, dare I bring it up, Chevron, to place your charging stations?
Yeah, we haven't so much locally because we've been mainly looking at the, sort of the level 2 charging, which the gas station isn't really that great a place to put it because,
Right.
You want to be somewhere where you're actually hanging out for an hour, or, at least an hour or two.
You have to be at least level 3.
And so we've been more looking at places like, the parking lot in the plaza where someone's parking, they're going to the farmer's market, or they're going to the restaurant, or they're doing shopping, or Old Town, or somebody's maybe working. That said, I think for the fast charging, like Oregon, I think has put some at gas stations where there's a coffee shop and there's a convenience store, and so you can stop and say, I'm going to be here for 15-20 minutes. I can use the restroom, get a hamburger, or whatever. And so for the fast charging, that's sort of a little bit more parallel, and so it makes more sense. But around here, it's more like, where can you park and do some business?
Yeah, mainly concerned about the outlying spots, getting something there so that I can make a trip down to the Bay Area and back.
Yeah, and that's where we were talking about what are places in Garberville or 301 South, or where there's something to do if you're parked there, at least for a little bit, or going north. Like I know the folks that have been working up in like Brookings, they were looking at like the Cutchell Visitor Center in Oric as kind of a spot where it's like, here's somewhere you can park, there's bathrooms, you can hang out at the beach, you can walk around, or like in Klamath, there's the you can gamble there too, but there's a little convenience store, you can get something to eat or get a cup of coffee and hang out for a bit. So places like that where there's at least some services to occupy your time.
I was just going to add one thing about, Colin, you had talked about the ownership model that RCEA is rolling out, and this first 9 or 10, actually 10 stations at 9 locations that are being proposed. The Schatz Energy Research Center and Dave Carter and PhD, we're actually doing one of the other regional planning studies for Siskiyou, Shasta, and Tehama counties. And so far, they don't have anything over there. They don't have a group like RCEA over there, an energy authority. And so far, nobody has sort of stepped forward and said, and actually Dave's exploring this a little bit, but stepped forward and said, oh, we'd be interested in developing a network of stations and owning and operating those stations. And I think one of the issues is, in terms of getting the infrastructure in place, even if you can get a grant from the state to put the charger in, once the charger goes in the state wants to make sure that that's going to be useful for years into the future. So there's issues of maintaining it. Actually, the charger in Eureka at the Fisherman's Terminal did really well early on, but within the last 6 months or so, they've had 2 vandalism incidents where someone's cut the cord off. So that's an expense to whoever owns it to maintain it. They have to deal with making sure that they're paying for the electricity if they're on the account of record and paying for with those kinds of stations that you can access on your smartphone and stuff. There's monthly fees, so there's just all that administration and management. RCA has stepped up and said, hey, we'll take this on. So there's much less of an imposition or a responsibility on the part of the site owner, not the site owner, but the site host. If you can find somebody who's willing to host the site, but doesn't have to deal with all the other stuff, RCA takes all that headache away. But they still have a site there that they might still attract customers to their facility because they've got electric charging. And so I think that's something that you guys have really stepped up.
And not to say obviously that people can't do, not like we have a quarter on the market or something, or so anybody can put one in. Caltrans put one in for their employees, and then they're actually getting fleet vehicles, so they have some already, and then they're putting them in for those vehicles. But it was more sort of as we were looking at it, it's like, well, okay, there wasn't any private company that was really going around and saying, hey, let's make this available, and again, trying to just push that and make it an option. When we went to the city of Trinidad or city of Ferndale, it's like, hey, you got this great parking lot downtown Ferndale. Would you like electric vehicle charging? Like, great, but we don't want to deal with it. We don't want to have to know how to use this thing and deal with billing people and dealing with fixing it and training our maintenance guy to have to deal with it. And so, especially in a rural area, just kind of for those kind of public spots or for small businesses that want to make it available but don't want to have to think about it.
And take the economic risk. I mean, eventually these things will start to be revenue generators, but at first they're not. You're going to lose, for the most part, you're going to lose money on installing a charger right now with the number of vehicles that are on the road.
In Oregon, they've taken the state has taken a very aggressive and forward stance of putting in this infrastructure up and down the I-5 corridor. Now they're starting to do it on the coastal routes. And my understanding is actually that the charging has been free so far. They're about to transition over to charging people for the electricity, but so they've taken that state has taken it on to put this charging infrastructure in there. It's a different approach, but
it's my understanding you have to get an aero fob.
Yeah.
And they're charging like a monthly fee for that now.
Yeah, that's what they're switching to, basically like, oh, you pay, whatever is a month, then you get to use the charging. Yeah, but it's their whole network is their environment. Yeah.
Kevin?
So if we're doing it on the Oregon coast, it sounds to me like that's as much a tourism initiative as it is local infrastructure initiative. So it seems like maybe one place to look for resources to do the large scale, high capacity level 3 charging on the 101 corridor to do the connection to the Bay Area to maybe 1 or 2 in Humboldt County would be to tourism agencies, state of California or local tourism agencies.
Yeah, the Oregon program actually, they kind of have 2 categories to their program. So they've got like the electric vehicle highway, which is like the interstate and kind of the connectivity. And then they actually have like an an electric vehicle byways program where they have actually sort of these curated vacation routes where you say, oh, okay, you want to go to Mount Rainier, here's the route, here's where the charging is, here's, specific places you can stop that are convenient, or here's the wine country Willamette Valley. And so they've actually kind of plotted it out and have those kind of tourist routes. So someone can fly into Portland on vacation, rent an EV, and do this
So then I would imagine it's not just Oregon Department of Transportation doing that, right? There must be some tourism agency that's supporting them in doing that because it's an amenity.
Yeah, and I think it was like the wine folks were like, hey, we want to have a wine route. What can we do? Can we work with you? And so the tourism folks were basically kind of reaching out to kind of engage them. And I don't know if EVs and drinking is the best combination, but their hotels is all the stops. But yeah, so I think kind of having those kind of partnerships where the industry was really reaching out and saying, hey, we want to work with you guys to have this, and so I think that would certainly be an option.
That's right. We need the Google cars that drive themselves, and they take you to the wineries and you drink what you want.
We need a drive-through tree and charge.
It could be an inductive charging as we go to the tree.
That was probably a good time to do it. I don't know if people saw like the New York Times had their like 50 top places to see on planet Earth, and like the northern coast of California was number 3. So nice.
So pitch it. And you got the new national monument or the expanded national monument.
What's the associated cost of like upgrading from like 1 charging into 2? Does it double it, or is that?
Great question. It turns out that the biggest expense is on the first unit, and in all of these plans, and Dave could talk about this more, but in all of these plans for all these stations that we're proposing, we're making sure to size the conduit that gets laid sufficiently so that if we want to add more chargers later on, it's much cheaper. It's essentially just the cost of the pedestal itself. So in some cases, we're even stubbing out the sites for the next several chargers. So you can save a lot of costs by doing it right the first time and sizing everything for where you want to be 10 or 20 years from now.
It's a tricky question. That's where the devil's kind of in the details. So part of the cost is getting the power to wherever you want the space to be. So if you say, oh, here's a great spot on this corner of this parking lot, and your panel's on the other side of it, and you've got a trench through the entire parking lot and lay conduit, it doesn't really matter whether it's level 1, just an outlet, or whether it's level 2, that could be your biggest cost right there. And so figuring out, and that's what a big part of the analysis that Dave did was like, okay, here's a panel, here's an ADA spot where we can get next to it, or here's a spot where we can create an accessible spot. And so really meeting those requirements, at least for the public side of it, can be the #1 cost. Then once you get to that spot, an outlet's practically free, or an outlet on a post, maybe a few $100s. You can get level 2 chargers that are maybe $500 or so. I think the cheapest one's like $300 something for the Bosch one. But if you want one that actually has like credit card enabled billing and kind of you can use like a gas pump and has data collection where you can see when it's in use, and someone can look on their phone and say, oh, that one's being used right now, I'm going to go to this other one. Those units are more in like the $4,000, $5,000, $7,000 range when you start having those kinds of features. And so that certainly is a larger expense. At the home side of it, you're going to have one of these few $100 chargers, where the expense there can really come in is if you have to upgrade your panel, like if there isn't the capacity on the panel. And one of the issues with that is it's similar to just having like a dryer plug added, which isn't that big a deal from an electrical standpoint. It's a little bit bigger deal because by the National Electric Code, it's considered a continuous load. So when they're having to size it, so when you're getting a building permit to do it, if you put in a dryer, they say you're not running your dryer 24/7, and so it's not a continuous load. If you want to put in an EV charger, they consider that as though you were charging all the time, just by what the national code is. And so, the building inspector is going to say, oh, well, your panel's not able to accommodate, the service isn't big enough to accommodate that, and that can be a barrier, sort of the residential side of it. The state is actually just this last week, this came up at the meeting I was at, and they said, well, gosh, we have this authority at the state level to, adapt. They have to adapt to adopt the code, but they can amend it locally. And so the state's saying, well, why don't we change that and just say, hey, it's not a continuous load, and we're not going to count it as that. And so that would eliminate some of those barriers for someone installing a home charger.
I wonder, because I talked to Reading Electric today, one of the guys in their distribution infrastructure department. He said that's the way they treat he made it sound like they treat, if somebody puts in a panel, they assume it's used 24/7 at the full rating of the panel. So he said in terms of like the assessment of how much peak demand is, he said, we don't really care.
Huh.
If someone's gonna put in the panel, we build the capacity to handle the full.
That's on the utility side of it, though.
On the utility, right, right.
This is more on like the building inspector, like, oh, is your, going to burn out your.
Okay, right. So, but I mean, if the utility is requiring, well, I don't know if they would require you to upgrade the panel or not.
I would add that at some point, adding that next charger is gonna trickle back into your service panel, even for your commercial installations. And it could even go back to the transformer at a certain point. And then the utility gets involved, there's some cost sharing associated with that. So each site's a little different, and the next charger can always bump you into that next range, so.
There's no one answer.
And that can get pretty expensive if you have to upgrade the size of the transformer that's providing service to the building.
I think we're out of time.
Thanks, everyone.